In this problem, the particle P starts from the rest and the acceleration is given as 2g, which is constant in the horizontal direction. So in this case, we can say that A is equal to 2g and theta is x, which is the angle with respect to x is equal. And also we can see here that the radius of curvature is 3.5 meter. So in this case, we have to find the acceleration just before the point B. It means that we have to consider rectilinear motion. So in this case, I will draw a line and I can show you that A to B is a rectilinear or linear line where the acceleration is equal at the any point as per given in the problem, that it is uniform throughout the horizontal way. So each point the acceleration is uniform, and so as it will be the constant at the point B, which will be equal to the 2g. Now we will solve for the acceleration at the point B just after it passes the point B. It means that we have to consider the curvilinear motion, and in this case we have to use an anti-coordinate. So I will draw here this A to B, and we have to consider the point B is on the curvilinear path. So in this case, acceleration will have two components. The one is an and another one will be the at. So the acceleration an can be written as velocity square upon the radius of curvature. In this case, we have to see what is the velocity at the point B, and then we can easily find, because the radius of curvature is already given to us. So an is equal to v square upon rho, the velocity at the point B and the radius of curvature at point B. And in this case, radius B is already given, so we have to find the velocity. So if we can easily find the velocity because it's a linear line, so we can write vb square is equal to the initial velocity plus 2as. Further, you know that the particle starts from the rest, so the velocity at point A is equal to 0 plus 2a is acceleration 2g multiplied by 3 meter length, which is A to B. So our answer for the velocity is 10.85 meter per second at the point B. So we will put the velocity in the formula, and we can easily find the acceleration in the normal direction. That will be equal to 10.85 square upon 3.5. So here is our answer. This is 33.6 meter per second square. What about the AT, guys? You have to think about the AT. AT will be in the same direction of the horizontal. When it will reach the point, okay, the B, it will have a same direction. I mean, the value will be the same for the AT at the point B. So in this case, we can say that acceleration AT at point B is equal to 2g. So as here you can see in the picture that each point will have same AT, and of course it will have the same value at the point B. Now suppose we are going to make a normal and tangential coordinate for this. So we can say that AT is equal to A, and the AN will be going to be 0. Now you have value for an and you have value for the AT, so you can easily calculate the total value for acceleration at the point B, and that will be equal to 38.9 meter per second square. Now let's make vector diagram for the AT what we have calculated and for the AN. So at the point B, AT will be linear to the horizontal line, and you know that AN will be towards the center, so you can easily make a AN line. The resultant A is shown as here, and there is an angle theta, so you can easily calculate the angle because you have already value for AN and AT. Put this value and take tan inverse, and you will get the value theta is 59.7 degree, which is with respect to x-axis. The angle is in clockwise direction, so we will write minus 59.7 degree with respect to x-axis. Now we are moving to the point C, where we will calculate acceleration at that point. And you can see here that point C is on a curvilinear path. So again you have to calculate the acceleration in normal direction and tangential direction, and we can calculate acceleration in normal direction using the same formula v square upon rho c. So in this regard we have to calculate the velocity at the point C. Again we are going to use similar formula to calculate the velocity of the point C, as you know that the velocity at point A is equal to 0. So we will put the value for the acceleration and the distance. Here the distance from A to B is 3 meter and B to C is a curvilinear path. It means that we have to take 1 by 4th circumference. So I will write 2 pi r is here 3.5 divided by 4, because this is a 1/4 part of perimeter or circumference, so I divided with the 4. Now the value for the point C is, the velocity is 18.26 meter per second. Now you have acceleration value and you can calculate the normal direction acceleration. So 18.26 square upon 3.5, that will be 95.3 meter per second square. The AT will be the same because it was uniform as it was mentioned in the problem. So I will write AT is equal to 19.62 meter per second square. Here the total acceleration can be again written as an square plus at square under root. Now let's make vector diagram for the acceleration, the both components. So we will first draw the tangent and the normal. Normal will be towards the center and the tangent will be the 90 degree to the normal. In this case we have drawn the acceleration in tangential direction and in the normal directions. The resultant acceleration is shown by green color and there is a theta. Of course, this theta can be calculated by using the tan inverse an upon the at. We have to calculate angle with respect to x-axis in clockwise direction.